at school I play a lot of poker and blackjack. They're a lot of fun for me to play. And it's not just me, it's a lot of my friends, and we have like this whole ring. We don't bet, of course. If I wanted to do that, I would just invest in some crypto. But so gambling is a lot of fun, and there are several reasons you would want to bring it on top of blockchain. One is trust. It enforces trust between different parties who are participating in a game, and for gambling games to occur, such as poker, you need some kind of randomness to it, and this is where we run into the problem. So you need random numbers for statistical simulations, games, and cryptography. And in other languages such as Python, it's pretty easy to generate a random number. So it literally takes 2 lines. But in Solidity, it's nearly impossible. And the question that is, why is it hard in Solidity? And the reason is, blockchain itself is deterministic by nature. So everything that will happen, there's some way to predict what's going to happen to a great degree of accuracy. And so let's step back a second and just refresh ourselves on what blockchain is. So blockchain is just a public ledger that everybody has, and it records transactions between people. So a block of transaction, just one block, and they're connected using hash functions. And to add a block, a miner such as Abhinav would have to do a very difficult math problem. And if he's successful at doing it, he can add a block and he's rewarded to that. And in the normal web, you have a very big application there, and you're not going to get a lot of money from protocols such as HTTP or TCP/IP. You're going to get money, or you're going to make money from things such as Facebook and Google on top of those protocols. But on the blockchain, it's the exact opposite. The application there is very, very small, and if you want to make money right now, you invest in Bitcoin, you invest in Ethereum. And there are 2 reasons for it. One is you can't have a lot of transactions going on in 1 second. And there are people who are fixing this. But the other, which is what I run into, is blockchain is deterministic. And you're only limited to on-chain data. So in my case, if I wanted to make a random number using only stuff that's available to me, which is one big thing available to me would be block number and block timestamp, which gives me details about the last block. People already know about that. So it's not truly random. And on top of that, if you want to use something that user inputs, the user has some control over what the random number is going to be. So this is where oracles, such as Oraclass, come in. So oracles, what they do is you just push in data to your smart contract. So how they work is you have a blockchain, and you have oracles that are listening to the blockchain. And let's say I execute a smart contract and I want to make a request. It would just send out a signal saying, hey Oracle, I have a simple request for you, and I also have a little bit of Ether as a reward for doing it. So Oracle is going to take that Ether, it's going to give back an answer, and a lot of oracles, they also give back some proof of if their work, that their work is trustworthy. And so for Oracleize, the one that is the biggest and the oldest in terms of Solidity, here are the 5 big commands that you can use. You can request data from Wolfram Alpha. The only problem with this is they don't return a proof for them. You can also request information from the IPFS network, which is the Interplanetary File Sharing System. It's decentralized storage. You can also request random numbers to be generated using the random function, and those are generated using ledgers that are running in their that they're running, and they will provide proof of that as well. You can do normal get and post requests for URLs, and my favorite of all, computation. So computation is just running stuff off-chain, and by stuff I mean files such as Python and Java files, and getting the data from them onto the blockchain and onto your smart contracts. So so there are certain limitations to this function, and that is that you can only run your virtual machine for 5 minutes, and you can only have a string of data that's around 2,500 characters long. So how does computation work? So first you make a zip file of a Docker image and any other file that you're using. So in my case, I wrote RNG like a random number generator in Python, which took 2 lines, and I also had a Docker image. I made a zip of that, and then I uploaded it to the IPFS network. And then the hash of my zip file is then sent to Amazon Web Services, where they unzip it, and they look at the Docker file, and then they run a virtual machine according to that, and they execute any files that you've also put on. And then Oracle takes the last string that was outputted, and it pushes it into your contract. So here is the Docker image. So, it's using Linux as a OS, and it's also using it also has a RNG file that is to the right, and it executes that. And once I made a zip of those two files, I uploaded it to the IPFS network and added a function. So looking at the function, we have two lines, which is first is Oracle set proof. And what it's doing is whatever proof that's generated, in this case, which is a TLS notary, which just copies all the stuff that's happening in the virtual machine, and that is upload. And then I'm saying that it should be uploaded to the IPFS network, and I should only return a hash of that. And the reason this is done is if you have a lot of data being pushed onto a smart contract, the gas prices are going to be through the roof, and good luck being broke for the rest of your life. And the second line, which is line 47, it is just saying run a computation from this hash address, which is a hash from a zip file. And once I execute the smart contract, it sends a query and returns a result, which is 1. And the Ethereum, which was in the beta contract I made, was given to the address that guessed that number. So what does this imply? That's the big question. Well, the biggest problem with Solidity is it's very hard to work with, and you can't really do a lot of complex stuff because of the fact that gas prices are going to rise the more complex the smart contract becomes. And so it's not economically feasible to make it very, very complex. And you can't really do a lot, of revolutionary stuff just on top of the chain, because there's a world outside the chain as well. So imagine you have, you're making insurances that are going to be given out to people if their crops don't receive a certain amount of rainfall. How do you do that? You can't really do that because that information is not on the blockchain. So you're forced to use oracles, that's Oracleize, to get that information and send people their money if those conditions are met. And also, you can also run a lot more complex stuff, such as AI, in a virtual machine and get the data from that. So imagine if you could just pull out your phone, take a photo of a growth of a wart or something on your skin, and it can analyze that off-chain and tell you if it's cancerous or not. And now that analysis that the AI did is now associated with your Ethereum address for the rest of your life. So say you go to a doctor, all he needs to do is search your Ethereum address, and he would have all the analysis that the AI did and why it thinks that it's the growth is cancerous or not. And another question that arises is why can't nodes get information directly from the sources? Well, the problem lies in the fact is in the way that these networks are structured. So a smart contract is executed independently at every single node. So if two nodes get different answers from the same source, well, now blockchain is useless because the nodes conflict with each other. So you can't really. So what you need is something like oracles that can get the information themselves and push it into your contract on every single node and make sure they're similar, so the blockchain itself doesn't break down. And the question that it raises is, we're still trusting oracles, and they have a lot of power over any smart contracts that are being executed that are using it. And in a sense, we're forced to trust it because we can't really expand upon the uses of blockchain because it's just a database. That's it. But and oracles also provide proof of what they're doing and how for example, Oracleize claims the fact that it's a mathematically provable, honest oracle. But the problem is we're still forced to trust them and all the data they gave us. So can we truly build a decentralized world where, without trusting these oracles, when we're forced to trust them from the get-go?